Good evening, everybody. Welcome this session. So today we are going to talk about a project which we have done in our company regarding the smart accident risk classification. Okay, so we have a traffic signal data. In that traffic signal data, we just want to do the classification where will be there be a chances to increase or get a accident. Okay. So, my name is Vikal Chauhan and I worked in this project. So, so this is our architecture diagram. In first, we understand the business, okay, then we store the data into the database, okay, in the tabular format. Okay, we done the data cleaning, normalization of the data and encoding and do some kind of feature engineering. After that, we stored the data into the MySQL database. After that, we train the model, okay, like we use the random forecasting kind of, not for forecasting kind of, it is a forecasting project. So we used random forest, XGBoost, LSTM, and kind of models. And after that, we have done the evaluation through F1 score or ROC score, okay. Then after that, we deployed that project or that application into the Streamlit, and after that, we made done the monitoring and maintenance for the client. You know what is the business problem we are facing? There is a high number of accidents occurring at intersections and highways due to unpredictable traffic, poor timing signals, and road conditions. Okay, because of that, at the intersection, the accidents becoming very high. So, what are our objectives? To minimize accident risk prediction accuracy. Okay, and what is the constraint? Minimizing the false alarm in prediction. The most important is we can detect sometimes the prediction of the accident, but sometimes there can be a false positive. So we have to minimize those things. So the when we got the data, collected the data, okay, so we have the columns like location ID, road type, lighting condition, weather condition, okay, signal status like red, yellow, green, what are the signals? Is there a signal in that particular road or signal? Okay, at what time we are doing that analysis? Okay, time of that signal. Okay, what are the enforcement level means? What kind of uh, government peoples or government officials, traffic police are there or not? So that enforcement level we are getting it is there or not at that time. Okay, day of a week, at what day, like the Saturday Sunday there will be a sometimes a huge traffic, or sometime Monday to Friday will be a certain time there's a huge traffic because of the people going to work or getting out from the work or getting leave from the work. So so we also have those that kind of data. Okay, vehicles per count per hour, at which hour the rush is high and low. So those things we have in these columns. So this is our data dictionary, like location ID, road type. These all are the categorical data, weather status, signal status. Okay, signal yes or no, binary like yes or no, like binary 0 and 1. Okay, hour of a day. These are in numeric format. Okay, time format, and enforcement level is also a categorical data is high, medium, low. Okay. Then day of a week also numeric, and vehicle count per hour is also a numeric data. Then we observe that there are some kind of missing value in lightning, weather peak, columns and traffic data also. Okay, their signals are some there. Sometimes there are signals and some there they're not showing the signals. Okay, and there are also one column called cause of severity. Okay, the severity of the traffic. So that kind of things are missing. In numerical data, the vehicles count per hour is sometimes missing. Average speed of a traffic flow is missing. Okay, sometimes the signals signals, color is missing. Okay, do it like green, red, yellow. Okay, so this kind of problems we are facing and when we got the data. Okay, so there's more columns like we got missing, so we do the imputation. So what the in rule based in Lightning, what kind of imputation we have done? Okay, so if in the weather column there are missing sometimes something is there. So we mentioned that if there is the weather according to the mode imputation, we done the imputation particular column. Okay, in traffic signal we also done the random imputation. Okay, sometimes the mode imputation will not work, so we use the random imputation. Okay, so and vehicles count and also that we also done the imputation, and in that imputation we involve the counts of the number. Okay, so at the duration, what duration we the missing value is there, according to those bases we done the imputation. So after doing the all the imputation of a missing value, then we clean the data. Okay, after the cleaning the data, we standardize the columns. Okay, if there is outliers, okay, vehicles count per minute. Okay, we detected the outliers of through IQR method, vehicles count per average speed, yellow signal durations. Okay, so and vehicles count at accident time. We also done then the standardization of that wins, and we are also done the winsorization if there are the outliers. So we done the winsorization of those particular columns. Okay, we also done the standardization by converting the name of the column to standardized like underscores we given the between the columns name. Okay, consistent naming convention we have given to the columns. Okay, so then after doing the all the cleaning process, we done the EDA. In the first moment, we taken out the mean, median, modes of the tables. Oh, sorry, of the columns. So in categorical data, we just mostly find out the mode, and in numerical data, we just find out the mean and median. You can say in the hour of a day have a numeric data and the mean and median is uh, equal. So you can say this column data is normal. Okay, enforcement letter, sorry, and day of a week is also the same, and the vehicles count per minute is also almost the same thing. So nothing is worry about in the we are looking from the first moment decision. In second moment decision also we find out the variance, standard deviation and the range of the column. So through that we are able to find that the hour of a day variance is 6.92 hours. So the deviation is little bit quite high. So for that we have to do the some kind of pre-processing step on that. Okay. Then after the day, then we have done the third moment decision. In that third moment, we look for the skewness of the data. So has signal have a negative skewness. So negative skewness means it's a left skewed. Okay. So left skewed data is there. And okay. Then vehicle count per minute also have a skewness 1.090. So the skewness is little bit 1.090 is not that much severe. It can be have positive skewness. So we can look as a symmetric. Okay, not that much of changes. So except of the hash signal data column, we have all things are good. So when we and then we have done the fourth moment decision in that we able to know the peak of the data. So all the columns have the almost normal tail. Okay. Then you can look for this other histograms of each and every column as in shown in this graph. Okay, and for regarding those columns, we have also done the box plot to know the outliers for the columns. Okay, so then we also do the time plot of each and every column. Okay, where we need to access the data regarding the time at which time the accident is high or at which time the accident is low. Okay, when the traffic is high, when the signals is high. Okay, so all those things we got it here in time plot or box plot. Then these are the ACF plot. Through ACF, we are able to know the predictions of the models. Okay. Then this is a PACF plot for no to the precision or you can say predicted signals duration. Okay. Then what kind of model we use? In first we use the classifier advantage. Okay, first training is the categorical data and into the numeric features. So handle then we handle the imbalanced data effectiveness of the scale of with scales and with the weight. Okay. Then we have done the random forest filter. So effective the learn the patterns in the false positive cases. So when sometimes we are getting the false positive, so how we are going to minimize those false positive cases predictions. Okay, so that for that we have to balance the class. So for that we have done the SMOT analysis, SMOT implementation. So through that the data got balanced. So because what happened that accident data is very low and non-accident data is very high. So because of that the model not able to get trained effectively on the accident data. So for that we have to balance out our data set. So we have done the SMOT analysis on that and then we train that model from the random forest. Okay. Then this is the accuracy. Okay. So we are getting the accuracy at 0.9776. Okay. If you see the stage 1 confusion matrix, here you can see it's 276 or sorry 278 false predictions are there. Okay, after doing the SMOT analysis and balancing out our data set, then we are getting the very six false positive answers. Okay, and six false positive answer. So you can see the how the SMOT analysis got the change in the predictions of our data set. And here you can see the precision call of non-accident is 0.9, F1 score is 0.99, and for accident it's giving 0.7, which is quite enough. We have a little bit less data, because of that we are not getting that much of high F1 score. But yeah, if we get more data, we can get able to achieve more than 0.9 or 0.95. Okay. Then we deployed our model into Streamlit, and our backend stack is from the Python. Okay, we also done use from the some of the libraries of the Python to drop a pipeline. Through that pipeline with the Streamlit, we able to deploy all our models and get the data and through that pipeline and deploy that model in Streamlit, and we able to get the predictions of the date and time of the particular day. So these are technical steps we have learned pandas, scikit-learn, Streamlit. Okay. So this is how our UI looks. Look, we have to give the location ID of which location you want to predict the accidental phase. Okay, at what hour, at what time. Okay, signals are there or not. All things we have to give the input. And on the basis of that, it will going to predict the risk of getting of accidents. Okay, so after that, we have deployed the things. We predicted the get little bit good score. Okay, then just a minute. Yeah, when you're going to give the date of the when you want to predict, then you have to give the location at whatever you want to predict. Okay, if signals is there, true or not, working or not, enforcement level, then day, weather is clear, rainy, road type is urban, vehicle counts per hour, what is the vehicle count at that time, and then you are going to predict the risk. So accident is there, that kind of you will going to get the scores and risk score and no risk scores like that. Okay. Okay. Then, huh. So what are the challenges we found to imbalance the data? I already said we use a smooth oversampling technique to balance out our data, and we need to we another problem we have faced, that false positive rate is very high because of the less accident data. So that is also a kind of challenges we faced. And we also face the challenge of data leakage. Data leakage means some of the columns we take, and at that through that we are getting very high accuracy. But what happen is that when we are going to predict that kind of scenario, we don't need those columns. Like there's a column called given that accident happened, severe accident, low severe accident. That kind of column is given. It's going to giving the grade of that particular accident scenario. But when we are going to predict those things, we will not get that kind of data. It's a severe accident or low severe accident kind of data. After have got happened, those things we going to get that data. So because of that, when we are going to taking that column, because we are getting the data leakage. So we are preventing those data leakage. Okay. Then feature engineering complexity, what we are facing here, we make 22 new columns to make our data concise. Okay. Then, the future scopes are real-time integration we can do with the live traffic sensors. Okay. Then we are going to do the operation improvement, like automated the alert system of the traffic authorities, mobile for the public awareness, integration with the emergency response. Okay, we can also scale this product through AWS, Azure, and all. Okay, so this is our the project description. Okay, so thank you all. We'll meet again.